Hello, people. This is like the third time this week I've streamed. I know. Finally, there's somewhat of a consistency. But, what was I going to say? Oh, yeah. Today, we are going to be studying AP Physics 1 for like multiple hours. Hopefully, like 4. Because school's starting up again tomorrow. Winter break's over, you know. Very sad, very sad. I have to see people. Today we are going. Oh God, my fucking voice. Let me get rid of that. Yeah. School's starting up again. I forgot everything I learned the entire semester. A lot of quizzes, as you can see. So we're gonna be learning it all again. Isn't that fun? We also have college AP classroom pulled up. We've got Khan Academy, and if I need it, I'll pull up organic chemistry tutor. In fact, I could ask ChatGPT to make practice questions. I'll think about that. You can see, yep. Ignore those. Okay, let me see. What was I gonna do? Voice crack. Okay, we're gonna start from the basics. We're gonna destroy College Academy, alright? We've got, let me see this. Okay, so in first semester, we only finished 3 units, now that I noticed. We did kinematics, force and translational dynamics, work, energy, and power. No clue what any of this stuff is. As you can see, I've spent some time earlier, not like today, but like months ago probably, doing this stuff. I thought would help, it didn't. There's also a semester final, which I exempted, and I was told I could still reopen it afterwards, but clearly I can't. But there's progress checks, which is awesome. Although the due date seems to have... Wait, no, that's for this week. Wait, no, I mean, that's for this year. Never mind, I forgot it's a new year. We're fine. We're fine. But yeah, no, I will be probably doing those later. He opened them like a month ago. Hold on. I gotta plug in the charger. Alright. Where to start? Where to start? Let's relearn stuff. Actually, organic chemistry. If it'll let me type chemistry, tutor, AP physics. We're starting with this. That is a lot of videos. Okay. I'm really bored, so I'm just doing this. Some of these videos seem somewhat useless.
I write with Grammarly.
Physics basics introduction is an hour long.
Such as displacement, velocity, acceleration, projectile motion.
You're kidding.
Newton's 3 laws, forces,
No. This is not the playlist for me. Hold on. This one. Oh, that's still bad. I want to find a way to pull up practice questions. I'm thinking. Wait, this might be awesome. Let's see if we can answer these. A car travels 100 meters north in 10 seconds. Average velocity. Is it A? It's A. Okay. So I know how to do that at the very least. 100 north minus 100 south equals 0. And then since I was just okay, 0. I didn't think of it like that, but I still got the same answer, so that's basically mastering the subject. Let me get a notebook for this. Hold on. And a pencil. I was very unprepared when I started the stream. Hold on, all my pencils seem to be somewhat broken. Okay, never mind, I got one. That's something. Alright. Question 2. What is the direction of the normal force acting on... Okay, well this one's easy. If you don't know normal force, what are you doing? Oh, frictionless incline, not okay. Perpendicular to the incline, and I think it's B. Parallel to... No? All these words. Technically, no. I think it's B. Yeah. Normal force always acts perpendicular. Oh wait, no, that's the answer, not the question. The car accelerates from 0 to 20 in 4 seconds. What is acceleration? I forgot the equation for acceleration. Let me get my formula chart. I really did bring anything up before starting this. Alright, there we go. Formula chart. Boom. I need some place to draw. Low key. Do I really have to? Whatever. Ignore my emails. Ignore my emails. What the hell? I wanted to be able to draw. Can I draw? We're not doing this. Whiteboard drawing. Please don't make me make an account. For work. Okay, we have a whiteboard pulled up now. Do. Alright, sweet. Sweet, sweet, sweet. Let me make it a little thicker because, like, look, I'm blind. Alright. Let me close out of these. Alright, what's the question? Where am I? There it is. Car accelerates from 0 to 20 in 4 seconds. So the equation for acceleration, that is... Oh yeah. X equals X, O, no. Okay, this is a little hard to do with a mouse. I've noticed. X, O, plus V, O, T, plus 1/2 AT squared. If there's anything to remember, it should be this equation. And so, what's the question say? What's its acceleration? It goes from 0 to 20. So we know 20 is x. X naught is 0. Does it start from rest? I think so. So we're going to do 0 plus 0. It's a terrible t. Another terrible t plus 1/2 AT squared. Oh, we know time. Hold on. 4 plus 1/2 a. We don't know acceleration, so we're solving, and then 4 squared. This equation got really easy. You can cancel out these. So that's 16. So 20 equals 1/2 a 16. We're gonna make that 1/2 a, so 20 equals, I mean, just a8. I put the equals on the wrong side. Divide both sides by 8, and that should be our answer. I need to pull up Desmos. because I can't do basic math. 2.5. The acceleration is 2.5. Is that an answer? Oh no. It's not an answer. It's 5. What? Oh my god, I'm failing. Why am I actually failing? I can't understand it. It's all in one freaking line. This makes no sense to me. I probably should have derived an equation before plugging in numbers, now that I think about it. Hold on. We're gonna... Maybe this will make it right. Let me just... Yada yada. I keep forgetting to derive stuff. Okay. A is over here. We're gonna make it X. Wait, what? I don't think I even need to derive it. Read that as A equals velocity minus U. What's U? I've never heard of this. Okay, I don't think this questions are gonna be working for me. Which means we're using Khan Academy. Okay, I don't think these have a timer, so low key, I'm just gonna do these. It's 18 questions. So fun. Two position vectors, magnitudes 5m and 10m, directions shown. Figure 1. Vectors. Oh, this is easy if they're added together. So 15 for this one, 5 for this one. Let's see. Because these are opposite directions, so you subtract these two are the same, so you add. Boom. Table shows the position and velocity of a cart on a straight track at several moments in time. Oh, fuck. Okay, so it's clearly going backwards. And it slows down to start going forwards. This seems wrong. This is wrong. It moved first in the negative direction. You can see it going backwards. It went from 1 to point A. So I think the only one that matches that is this. These are like easier than the test questions. That's what I'm concerned about, because the test questions always like repeatedly beat my ass. The mess is retracted, but okay. I can't see what you said. Let's do it in the X direction as the first change of position. Change in X1, then change in X2 in the opposite. What? I'm already overwhelmed. This is great. What does this mean? One half of change in X1 equals, wait, no, not equals, is less than, huh? One half of a variable is less than a variable, and that's less than the actual variable. So, what? Am I lucky? Need ChatGPT. Bye bye, Ali. Why isn't anyone watching? It's physics, man. That's all I can say. What the hell is this? I probably should have drank coffee, lucky. But we're fine. We're fine. 1/2 AX. Where did that A come from? Why did I say A? Okay, we're gonna plug in our own numbers. Imagine x is 5. x1 is 5. 5 1/2 smaller than, let's say this is 3. This is smaller than 5. Right. Huh? Okay. We can confidently say that x2 is smaller than x1. It's also in the negative direction. You gotta remember it's negative, I guess. They're in opposite directions, so you would subtract them to get x total. I think it would be x2 smaller than x total smaller than 1. Because x1 is no matter what the biggest. So they're in opposite directions. To get x total, you would have to subtract them from each other. There's a timeout function? Are you kidding me? Whatever. This one doesn't make sense. I think it's this. The key. Hopefully it shows me on my grade. Carts A and B are identical on horizontal tracks. During 3 seconds interval, velocity of cart A changes from 2 to 5. So we've got our time, we've got our velocities, and we also have a second time, and then second, what? Okay, so we're solving for 2 different accelerations, or average accelerations. We've got this one for cart A, and then another one for cart B. All right. Also, we're gonna make this thicker. I gotta refresh. I can be generous with the space. We have a lot of space. Oh, come on. Whatever. This is fine. I'm just trying to be like organic chemistry tutor. Alrighty. I probably shouldn't have erased that equation now that I think about it because I need it again. X equals x naught plus v naught t. That's a terrible t. I can't do t's. Plus 1/2 a t squared. Okay. And for cart A, so we're gonna put cart A and then cart B. I really need a drawing pad. All right, so it goes from 2 to 5, and then this one goes from -1 to 3. I keep losing the tab. Oh my god. Okay, so 5 is the final. Wait, this is velocities. Why am I? Huh? I'm not. Why am I using this equation? Okay, wait. Let me just put a different one. V equals v naught plus a t squared. Is it squared? No, it's not squared. Just at. Okay. These are probably like the 2 main equations we're using for this first assignment. There's also another one, but I don't see us using it for a while. It's much more rare, in my opinion. Okay, so it goes from 2. So wait, so it ends at 5. So 5 equals 2 plus. We're looking, and we're solving for acceleration on both. So. And this one was in 3 seconds. Yeah, 3. And then this one, it was ended at 3, but it started at -1 plus a, and then I think it was 2 seconds. 2 seconds. Okay. We solved for both. Or I probably should have derived for acceleration again. We're gonna do that because I feel like it's the proper way to do it, and I just never care to. Also, how do I just move my mouse around? Oh, there we go. All right. To derive a from here, you do v equals, first thing you gotta do is, I'm assuming, subtract v naught, so v minus v naught equals at squared. I'm gonna just at, divide both sides by t, so you then get v equals v naught divided by t equals a. So we're gonna be using this equation for both. We ended at 5, so 5 minus 2 divided by 3 equals a. And then 3, what was it? Oh, wait, I also have to, wait. We gotta remember, it's already -1, so when it says minus, you do minus minus, so the 3 plus 1, I'm guessing. Unless I'm stupid and wrong. And then 2 equals a. Could always plug this into decimals, or we can try doing math in our head. 3 minus 2, 5 minus 2, that's 3. 3 divided by 3, a is 1. It's an ugly a. 3 plus 1 is 4. 4 divided by 2 is 2. So then a equals 2. And that gets us a. Hooray. I'm not sure if that's right though. We can always ask ChatGPT or Gemini to check. We'll do that at the end. Okay, from time t equals 0 to time t equals 10. Object moves. See, it uses so much filler to confuse you. I hate it. Because like this is what every test in physics does. All this, you can just say it's moving forward. Speed then increases as a function of time. Like, bro, whatever. The following methods would give the most accurate estimate of the instantaneous acceleration at t equals 5 seconds. So it's definitely not this. Why we don't need decimals here. Instantaneous acceleration. Acceleration is the change of acceleration. I mean, the change in velocity over time. So this says change of velocity. This is average acceleration. I don't know about that. See, both of these say average velocity. Wait, no, this is average. I meant to do this change of velocity. Why does this one have decimals though? I should have probably thought about that for a little longer. Wait, I'm low-key confused. We can always put it in an equation and solve it with our own numbers. I'm thinking. We're not gonna erase any work. We're gonna move downwards and just like at the end of this, I'm gonna zoom out and just like save the image. Okay. I'm gonna guess I can try plugging it in using the first equation. Actually, do I even want to plug in stuff? I'm overthinking this probably. Why would we need decimals? And would that logically work? We're finding acceleration. Acceleration is... Can we use either one of these? Oh, I lost. Okay, so let's say Crap. I actually don't know. I won't lie. They both sound somewhat sketchy. Because with this one, you would assume you divide by 2. And this one's, wait, divide that by 0.2, so then. Huh? I think this is more accurate. I think. We're gonna flag this one for later. Okay, we got a car. It's at rest. Okay. It's at rest position X from time 0 to 1. So it's at rest for a full second. Then by 5 seconds at 40 meters. Times 10. Oh no, and at time 10, then it's at, so it took 6 seconds, well, no, 5 seconds to get another 40. Is the average velocity of the car between 0 and 5 less than the, oh my god. Kill me. Actually kill me. Let's think. Hold on. Okay. What if I just tried plugging in this first equation a bunch? Crap. So it took 4 seconds to get to 40 because one of those seconds was just them, I don't know, doing nothing. And then they spent another 5 seconds. I forgot how to do average shit. No. I actually forgot. I have written on my formula sheet that, let me put this up here. Average, no, it's V average. V average equals change in time, I'm gonna change in distance over change in time. So we're gonna start with that. Oh, that makes it a lot easier, actually. I just wasn't thinking, I guess. So, the change in time between 0 and 5 is 5. Wait. No, that's what I'm talking about. Distance. And both of them have 5 seconds, and both of them have the same distance. Are they just equal? I think they're just equal. Because if they both go 40 and they both do it over 5 seconds, then boom. Yeah, no, it's just, oh my god, I overthought it. I'm so smart, guys. Okay. Is this even recording, Lucky? I forgot. Okay, no, it's doing crap. Ball is thrown up vertically into the air from a height of 2 meters above the ground. The initial velocity of 15 meters. So this is definitely like a parabola. Do I remember how to do any of this? Nope. At least there isn't air resistance. That's always something. I think A is wrong. I think velocity would be a bit slower. I mean, a bit faster. Because you got to think about parabolas. But this one should be the other way around. Okay, like this. Throw it up. And then if they threw it from here, then we would say like what? Okay. This is unrealistic. It wouldn't be speeding up going upwards. Just flat out doesn't make sense. Because, you know, gravity's always pushing down. Okay, so we're gonna have two left. At height 12, it would be going down. Or at height 2.5, it would be going. Whoa. Okay, this one doesn't make sense at all. So as soon as we let go of the ball and it just went up a little bit, all of a sudden it loses 15 meters per second. No, I'm picking D. What the heck is this? Graph shows position X as a function of time T moving along a straight line. Okay, so since it's curved, it's not constant. Since it's straight, it's constant. So it's accelerating at T1, moving constant speed at T2. That's actually pretty easy. Wait, let me read that again. Okay, we're fine. Cart moves along a straight line. Cart's velocity is a function of time. What is the ratio of the magnitude of the cart's displacement? I know there's a way to find displacement on graphs by like calculating the area, but the great part is I don't know how to calculate the area. I think we can ignore the bottom part. So then you just do area of a triangle, which is 1/2 based on side. So then 2 times and then 0.5 for the area here. And then 2 plus, or not plus, 2 times 3, and then 1/2 that, so 3. So 1 to 3. Oh, that's not an answer choice. Oh, no, 0.5 to 3. And then if you ratio that up, it's 1 to 6. I did that all in my head, baby. Oh yeah. Oh yeah. Let's go. It's probably wrong. I won't lie. Okay, refresh. We have that still. So the toy car moves along a level track. Coins are placed besides the car's position every second. Okay, so clearly it accelerates and it decelerates. Acceleration is not constant, that's true. Acceleration is not constant. Both of these are wrong. Acceleration is clearly changing. I guess would both of these be considered true? Um. No. This one couldn't be true because it could also apply like maybe the spacings are getting um. This is just if acceleration is like constant. It's not zero, but it's still constant. Probably. Okay. Airplane travels with constant speed. VA. I didn't mean to do that. I hate all plane questions. Every question about a plane is like pissed me off. Wait, what? I thought I understood it and then I misread it, I think. Okay, so it's going to the right at a constant speed. Relative to the air? What? Oh, God. No, relativity. No, I hate frame of reference or frame of motion. I hate it. I hate it. No. Whatever. The air is not moving relative to the ground. What the fuck does that mean? Okay. Okay, the air is not moving relative to the ground. I was taught frame of reference or frame of motion from like, what do you see? But you don't see air. How does ground see air? I'm a little confused. Okay, let's just say air resistance is 0 on Monday. And on Tuesday, there's wind and it moves. So there's air resistance on Tuesday. In the same direction as the airplane. So that means the wind actually boosts it. Oh, I'm getting this question wrong. What did those even say? Can't read. I hate this. It's just whatever's in the parentheses. I'm like, so I forgot I could do that. I forgot I could do that. I was like leaning 5 inches away from my computer screen. What does relative to the air mean? Genuinely, what does that mean? Okay, let's think about this. VT should be bigger than VM. I mean TM. Wait, no. TT is bigger than TM. Because the air is actually in its favor, right? So whatever's in this parentheses, has to technically make TM smaller, because wait. You know, TM has to be smaller, isn't it? Because there's no wind boosting it. I think it's this one, actually. The difference of the two velocities. Imagine you had. Imagine if at both times the velocities were 2, and to compare, like, I guess ratio to kind of ratio this, then you would divide it together and then multiply it by the TM, right? You know, TT is bigger than TM, so this ratio has to end up making TM smaller. Wait, so then would it be? Or no, it would be this. Because VA is it unaffected. VA is just a normal plane ride, but in Tuesday, like, VA represents just like how it would be like if nothing's going on. If there's no air, if there's no nothing, it's just normal plane moving. But then on Tuesday, it has VA and VW because there's wind. VW is the wind, right? And they're both going in the same direction, so it actually works in favor of the plane, speeding it up. So when it says VA, that's Monday, right? And then to ratio it, you divide it by Tuesday, and Tuesday has both of them. And the dividend will end up, the denominator will end up being bigger than the numerator. So then it creates a number that would be smaller than 1, I guess, like 0.7 or whatever, for example. And then multiply that by TM would make TM smaller. So I think it's D. I might be like pulling that out of my ass. I won't even lie, but I think it's D. All right, that felt good. Cars A and B are moving with relative speeds to the ground, indicated in the figure. Positive directions to the right. Oh God, relativity. I hate it. But I started understanding it when I started driving myself. I'm like, relative to me, this guy's moving fucking fast, you know, like I'll be in a 40-mile-per-hour zone, and then this guy's like going 50 something just to pass me for some reason. Like, God, we're not getting to the same place. Relax. But yeah, and then I was like, oh wow, well, the ground sees us both going fast and even faster, right? So that kind of helped me with relativity, low-key. So let's see this. What is the velocity of car B relative to car A? So in car A's eyes, like, if you're on the passenger seat, just like looking off into the outside of the car, it looks like car B is actually going backwards. So you can automatically, because it's not going forwards to you. Otherwise, car B would be speeding past you. It would be more than 30. It's 10 though. So obviously, you would subtract these two. It's obviously B. If it were minus 30 ms, then this car wouldn't be moving at all, and you'd be just zooming past an unmoving object from the ground's POV, but from your POV, it's literally just going 30 meters backwards. 30 velocity backwards. Yes, okay, I got it. I really want an actual whiteboard in my room. Like, to have a huge whiteboard where I can write stuff, that'd be my dream. That'd be, like, so cool. Sheldon. I'd be like Sheldon. Train in the positive x direction with speed relative to ground. Oh, crud. It's more relativity. Great. I understand the cars ones, but, like, since when have I been on a train, you know? Train rolls a ball across the table. Negative. Relative to the train. I'm picturing the event in my head. If we're on a train, a kid's pushing a ball, and then someone stomps the ball and then pushes it back. Velocity relative to the ground. Oh, great. And then there's VT. Where's VT? So relative to the ground, and then this is for the ball. Velocity of the ball. So if the ball wasn't moving at all, then it would just be VT. But it's moved backwards in the opposite direction, so it should be less than VT to begin with. So this doesn't... What the hell is this? I'm gonna ignore that for a moment. Anything more than VT should be wrong. Wait, no. It should be less than VT. So both of these are wrong, but these two have less than VT, which is good. And then it, yeah, and then I know it's B, but how do I prove it? Okay. So they're both obviously going in the opposite direction of VT, right? It's just that VO should be a little bit smaller than VT. It shouldn't be a completely negative. I think oh, I can't pronounce my THs. If it were literally in the negatives, then imagine a flying ball outside of the train going in the opposite direction, almost the speed of a train. That doesn't make sense. So I'm gonna pick B. We're almost done with this one. Oh no! I forgot all about what's it called? Pre-calculus? What is it called? When you got triangles? Trigonometry. Yeah, I don't know any of this. I won't lie. I might have to search up a video. Golfer strikes a ball that is initially on the ground. The ball leaves the ground with initial speed VO at an angle theta to the horizontal towards the vertical wall. Clearly they hit a window, as you can see. Terrible human being. Ball collides with the wall. At the instant it reaches what would have been the highest point at the wall. Wait, what? Ball collides with the wall. Okay, so this is the tippity top of the parabola. The highest. Also means it had a velocity of, I don't know, an acceleration of 0 at that point. Fun fact. Ball rebounds from the wall with the same speed it had when it struck the wall. Okay, so he hits it, it goes, and then he hits it at the top of the parabola, and it goes literally right back to him. That's not how it would have worked in real life, but okay. Because a lot of that would have been lost with heat and air resistance. But I'm overthinking it. It fell back to him. All right. Which of the following is correct expression for the horizontal distance between the ball's initial position and the wall? So we're seeing the distance between here to here. Now, while I don't know how to derive the equation, I do know how to bullshit this a little. Whatever these equations are trying to solve, it's for the entire parabola. So it goes up here and then it'll also go all the way down here, right? That's what the entire equations are solving. But since it only goes half that distance because this is the tippity top, this is 1/2 of the parabola, but we're not doing the other half. So it divides by 2. I can tell that, probably. I'm kind of pulling it out of my ass here. Would I need both sine and cosine? I've never seen that. Let me see if my formula chart has anything about this. Well, I'm not really seeing anything about it. That's great. That's actually great. I think I saw for X and Y. No, I'm almost only for X. So then it would be the sine of theta. Wait, no, cosine of... Wait, no, sine of theta would have been for Y. because here's the triangle, right? Opposites over here, so that's sine, and then that's cosine, right? I'm really thinking. I don't understand why A has both sine and cosine. I'm trying to process where they got that from. Maybe it's trying to bullshit me, but maybe it's also right. Either way, I'm confused. I just realized that C is sine squared, which worries me even further. Great. You know, since I'm seeing velocity squared on both, I think I have to use the third equation. Which would be, whoops. Let me bring the size back. All right, the third equation. It is v squared equals b squared naught plus 2a, and then parentheses x minus x naught, or the change in x. That's it. Seeing v squared on both are the answer choices. Applying to colleges, so I'm a sophomore. I'm taking AP Physics really early, so no, I'm not really applying to anything yet. I don't have my sights on anything. I still gotta figure out stuff, you know. I'm at that phase. I took AP Physics for fun, and it's not fun. Not recommending it in the slightest. I'm not looking for colleges now. Okay, let me see. Where was I? Wait. Ah, crap. I think I see a possibility where I need sine and cosine. I'm really thinking harsh about this. I feel confident on the 2G part. 2A. 2A. Acceleration would be... Is that where the sine theta comes from? Wait, okay, so sine theta, right? I'm thinking. Sine theta is just the height, though, right? I don't see how that's acceleration necessarily. Crap. I'm actually thinking about this. I don't think it's sine squared. Sine and cosine maybe something to do with the unit circle, like circular motion. I don't think so. There isn't really anything circular. It's just like golfer hits the building. It's like a parabola, and then at the very tippy top, like the vertex, I think it's called, it just bounces right back to him, and then I'm like calculating horizontal distance from that. And I'm trying to figure out. I'm stuck in between these two. I'm really trying to think. This is a little bit of a pain. Sine theta, cosine theta. Sine squared theta. That doesn't make sense. Sine squared theta does not make sense. I've never seen that ever. I'm just like, I instinctively want to press A, but I don't understand why I would press it. Like, it seems like the only one that's valid in my eyes, but I don't get how to get to there. It doesn't make sense. But I don't like this. It's sine squared. That's... I've done a semester's worth of physics questions. I've never seen sine squared. So we're just gonna pick that, and hopefully I understand what it means later. Okay, ball is kicked at a 30-degree angle above ground with initial speed of 12. Immediately before the ball returns to the ground. Okay. Oh, this is just split into components. Okay, I can do components. I know components. Come on. Okay, we're gonna do this. 30. And initial speed of 12. Crap, I forgot the way to solve for this. Like, it's something we learned years ago. I think. Like, sine to the power of, like, -1. I don't know. I need to plug this into Desmos somehow. I forgot trigonometry. I literally forgot basic trigonometry. I'm trying to think. It's like sine -1. No, sine 30 negative? No, that doesn't make sense. I forgot the equation of. I probably look stupid right now. What the hell's arc sine? I haven't heard of that. It's probably something I was supposed to learn in calculus or pre-calc, but I'm not even in that class, so that's great. Okay, we're gonna try arc sine. Arc sine. Whoa. I don't know what that means. Okay, this is gonna look really stupid. How to find sides of triangle with an angle. This is not what I was looking for. There was a simple equation that I've seen. I know SOHCAHTOA. But if I already have an angle. Let's try that. I just gotta remember the equation. I feel really dumb.
Draw something like this, and I'll say, here's A.
It's gotta. Okay.
Here's the angle. Alright, it's pretty easy to convert 3/4 to a decimal. So I'll just use it as
I
a
don't
decimal.
think.
It's gonna be primarily
No, this is not the video I need. Just show me the equation, please.
So we can easily find symmetric ratio.
I don't think
No.
this is not it.
Triangle if you are given with one side.
Where's the equation? I just gotta search up the freaking equation. Arc sine is a reverse trigonometry. So wait, so if sine 30 is 1/2, arc sine is 1/2. Wait, no, arc sine 1/2 is 30. Inverse? Is it inverse? I heard one of my friends talking about that, Loki. But a radian, so pi divided by 6. You know, I wish I could understand what you mean, but I'm not that advanced. I still need to take pre-calc and calc. Oh wait, this is it. He's gonna show me the equation. What can I plug into Desmos? He didn't really show. He's doing SOHCAHTOA? Oh my god, wait, it is SOHCAHTOA. I'm stupid. Wait. Is it SOHCAHTOA? So, hold on. Okay. Opposite, hypotenuse, adjacent. What? I don't think I can solve that. Don't I need two sides? I'm thinking. Wait, maybe if I pull up a calculator, it'll show me the equation. Because I know there was an equation. I probably knew it last semester, but then I forgot it. Well, no, I did know it last semester, but then I forgot it. Wait, no. Oh, this isn't it. Triangle calculator. Okay, let's say this is 30, right? This is 12. We know that, I think one angle has to be 9. Wait a minute. I'm so stupid, I'm so stupid. Bro, there was a theorem? I might have missed it. Lucky. The side opposite of the 30-degree angle. No, right angle, it's 1/2. Yep. I'm stupid. I might have forgotten that. I forgot it was a 90-degree angle. What am I doing? Like that. It should have been that easy. Oh well. 90, then this is 60. 30, 60, 90 angles. I forgot those, but I think it was like square root 2, right? I need to see what you said. The side opposite of the 30-degree angle in a right triangle is 1/2 the hypotenuse. Yeah, so 6. I think I'm solving for horizontal. Let me see. Horizontal. So then, now I can do SOHCAHTOA, right? I actually forgot all of trigonometry. I won't lie. SOHCAHTOA. So if I'm solving for A, what am I saying? I might have to reteach myself SOHCAHTOA, or not SOHCAHTOA, trigonometry after this. Trigonometry for beginners. Boom.
It's basic.
Adjacent over hypotenuse. Wait, cosine. I think I'm just saying shit now. Alright. The side opposite of the 30-degree angle in a right triangle is 1/2 the hypotenuse. Yeah. This is really basic trigonometry, but I've genuinely forgotten it all, and I'm a little disappointed in myself. I'm trying to remember how to do this. I could just do Pythagorean. A squared plus b squared equals c squared. Let's do that. There's probably a way easier way to solve it. I won't lie, but it happens. I don't think that's the answer. Oh no, that is. Woo! And it was here all along. Because I'm just that. I'm a little blind. Okay. We're almost done with. The message is redacted, so I unfortunately cannot see what you said. But yeah, Pythagorean. I probably mispronounced it, I won't lie. Alright, let's see this one. Student releases 2 identical balls off the edge of 2 different tables. Racing the edge. Wait. Figure 1 student races the ball from the rest at the edge of the table. So he just drops it, so it's in free fall. And then this one, it's like technically projectile motion, I think. Well, it definitely has a. Okay, this one doesn't have horizontal component. This one does. Let me see. Table in figure 1 is taller in figure 2. The ball in figure 1 reaches ground speed 1, while the ball in figure 2 reaches ground speed 2. This one has more time to fall, so I'm guessing V1 is bigger than V2. Although I'm probably just like lucky tricking myself. It could also be this, because like hypothetically, let's say, yeah, sure, the table's a little bit taller in figure 1, but what if I like deadass just launched it from table 2, like I pushed it real far, like real hard, you know? So I feel like it might be D. I know for sure it isn't bad, and I don't think that makes sense. I don't think you can say they're equal just like that. It might honestly be D, in my opinion. I feel like it's D. It can't be determined without knowing the relative heights. Yeah, sure. If they were both being dropped, then yeah, figure 1 is definitely bigger than, V1 is definitely bigger than V2. But since only one was dropped and the other was like flat out tossed, kind of, from the table, you don't know by how much, like how hard they tossed it, then yeah, I guess I feel like it has to be D. Yeah. I'm trying to reason with myself. Let me drink some water real quick. One question left. A launcher can launch a projectile with initial speed VO from the edge of a tabletop at any angle between 0 and 90, both horizontal. Okay. How does the horizontal component of the projectile's velocity change as... Oh, that's easy. All right. Let's see. Oh, but I don't remember if it's constant or not. I remember this was a test question. I couldn't remember if it was like a constant change. That actually angers me. 45 is the perfect like balance between vertical and horizontal, but we want completely horizontal. So its maximum value would have been at 0. It definitely doesn't increase. It decreases, if anything. It doesn't decrease. It doesn't increase from 0. I don't know. I think it would be constant because then again, horizontal components change constantly. Unlike it's like constant changes. Unlike in vertical, where it's I'm pretty sure it's more parabola like. So I'm pretty sure it's actually A. It wouldn't make sense for it to increase magnitude because horizontal. Yeah. What was that one question I didn't answer this one? Oh, I accidentally skipped 7. Let's see. The ball is launched vertically down with initial speed v1 from the edge of a table. It's launched, so there's force in it. What does it mean by that? I'm gonna just assume it's rolled off the table, essentially. The ball reaches the ground in time t1 after it's launched, which is the correct expression for the speed of ball before it touches the ground. It might be B. Wait, let me check. Oh, I didn't mean to save this one for last. It was I meant to cross out these two at the start. Decreases from maximum value to 0 from increasing magnitude. Personally, actually, wait. I'm really trying to think about this one. Maximum value to 0. That implies that it's more like exponential, no? I'm trying to picture it in my head. Kind of like throwing a football. I feel like I would go with A though. Just because when you're like calculating, this could be like the worst reasoning ever, but like when you calculate horizontal velocity in like a projectile and anything, like horizontal part's always constant, unlike vertical. I don't know how to explain that or like draw it. Might have to pull up organic chemistry tutor. You never know. But yeah, I'm gonna keep it for A for now. But if you're right, but you might be right. I won't lie. All right, let me see this one. Ball is launched vertically down from height h. The ball reaches the ground. Time t after it's launched. Okay, this one is probably really easy. I'm just like stupid. It's probably not 0 for being honest. When it says launch, does that mean at rest and then dropped? See, that's my issue. That's my issue with the wording. It's always the freaking wording on this stuff. Let's just think about this. V equals acceleration divided by time, right? Wait. Yes, I think. I've forgotten the most basic like principles. Okay. Velocity is change in speed over time. That's what I meant. Wait, is it? I'm lucky cooked. It says V1. Wait, what? About this one? Oh yeah. Oh yeah, crap. I'm stupid. Thank you. Yeah, no, that makes sense actually. Oh, boom. Wait. That's literally just the first equation. V equals V naught plus AT. Yeah, no, that makes a lot of sense. I'm just bad at reading it. I don't feel like looking at this question again. Might be hint that it's not dropped, but yeah, I feel like you're right on that one. It's literally just our first equation. I gotta keep refreshing this. But yeah, no, it's just this. Hooray. Oh. If you're not sure. Well, personally, to me, it makes sense. It says launched vertically down. So it sounds like... I don't think V1's towards a horizontal launch. It's vertically. The height divided by time doesn't make sense to me. This answer choice doesn't make sense. So it's either GT, so like change of gravity over time. No. I don't think it'd be A, because then again, yeah, no, there's an initial speed. So you have to include the initial speed. So yeah, I think it's C. I keep clicking the wrong tab. Let's turn this in and see what I get. This is gonna be bad. I won't lie. Completed. Let's see. Where'd it go? Oh, he has to score it. I don't even get to know. Great. Maybe refresh. You know, this could be an assignment we do in class, and then which I'm gonna look a little stupid. But then again, he's like really chill. Yeah, if the GT is just free fall, that's what I was thinking. But since it got that V1 speed, then you gotta include it. Because I don't think that one is free fall. Oh my god, this one's 30 questions. Great. This was, I think, my weakest unit. Wait. No. The third one was my weakest unit. Because I think I was absent a couple times. Like, I was pretty sick for like a week straight. And then I came back and all of a sudden there was like power, K, like so many different types. It drove me nuts. I did really bad, I think. Of course, we kept an A. We kept an A in the class, but, you know. Let's see. 3 objects are looking at XY plane. Center of mass. Oh, I forgot center of mass, dude. He taught us center of mass from like a ruler and then placing weights on it. I don't know how that applies when we have a Y dimension though. This exact type of question was on the test too, I remember. Or like on a previous test. I remember eyeballing it, but then I eyeballed it wrong because I didn't read all the answer choices properly, I guess. Okay, we're gonna think about it like this. I don't know how to exactly calculate it. That's my issue. I don't. Actually, wait, no, I can calculate this. I don't think I calculated it on the test because I had 2 minutes for this question because it's like on average we have 2 minutes per question. He'll give us like 10 questions and then 20 minutes in total, and then it's like a nightmare to try to do stuff properly. So we can just wait. Can we just use averages? Wait, no, but there's masses involved. I don't. Wait. MA is the lightest, so I'm gonna care about this one the least. And it goes 3 kilograms and then 5 kilograms. So it should be pointed towards this direction somewhat. I'm assuming. Okay, so 2 kilograms. Wait, let me see the first entry. 6.6. So about right here, and then 6. That nah. No, that doesn't work. Because this is only 3, and then on this side there would be like 6, so it should be more over here. So we're gonna count that one off. 7 and 7. All the way up here. It's above both MB and MC. And those are the heaviest ones. I mean, if MA was substantially heavier than both of these, then that would make more sense, but it doesn't, so I'm going to cross off that. All right, and 7.3, 6.7. So 7.3 is like right here. 6.7 is like right here. That just seems more like the averages of all of them together if they were the same weight. That doesn't really, that one doesn't work out for me. I'm not going to cross it off yet, though. And 7.8, 5.2. 7.8, 5.2. It's like right here. This one makes more sense. This one makes the most sense to me. I want to pick this one. Might just be true. But I don't really got the time to play that in. Like, a normal test, like, if I was just doing these questions on my own free time, yeah, I could take all the time in the world. I'll do whatever formulas I can to, like, ensure I got it right. But 2 minutes per question, that doesn't really leave the time for you to, you know, like, do all that. That's the worst part about the class. If I just had, like, the whole class period to do a test, I would easily, not ace it, but, like, do good, you know? But the time limit is just so terrible. Alright, let's see this. A rope is attached to the crate at an angle to the horizontal. Rope pulls the crate to the right. Constant speed. Okay, this makes sense. That's friction. That's just the force. Normal force as well, and then gravity. The surface. Wait, what am I trying to answer? Which of the following 3 diagrams can show the forces zeroed on the crate a short time later? Oh wait, what? As the crate moves across the surface, the coefficient of kinetic friction of the crate. So that means there's more force horizontally. The coefficient of kinetic friction between the crate and the surface increases, but the speed of the crate remains constant. Okay, so they still gotta add up together to cancel out, I'm assuming. What if I start off with 2? I'm really sorry. You probably typed that in like a while ago, but the issue with like YouTube streaming, it might just be a me thing, but genuinely I get chat messages just super late compared to, like, it'll show up like a minute after you said it on my end, and then, or maybe like you send it and then it takes a while for me to like respond. There's a delay basically. I'm free to, I'm down to go back to that question. Like, I'll flag it for later, if you want to revisit it. But yeah, get the distance of the renter between them, which might just be a ratio of the weights. Oh no. Get the distance of the center between them, which might just be a ratio of the weights. Wait, let me see. Let me see what we're trying to talk about. Let's get the center between them. Okay, let's do horizontal center 4, 8, 10, and then together. I can't do that in my head. Divided by 3. So about 7.3 without weights. This is without weights. And then, oh, I hope this is what you meant. I'm not entirely sure. T6, 12. Okay, so yeah, no. Answer choice C was literally if they were equal weights. And the one, wait, find a point which is this. Let me find a point which is center for 2. Okay, now I'm low-key a little confused, but what do you mean? Find a point which is a center for 2. I might just be stupid. I won't lie. I don't understand what you mean. Sorry. But yeah, no. Turns out I could have plugged into decimals pretty quickly. I guess when it came, because I'm pretty sure I got that question wrong on the test too. I think I overthought it and then picked the wrong one. But you know, I should have plugged this in. This is so much easier. It will not be in the middle, but it will be more close to the one that's heavier. Start for just 2 points of choice. Oh, okay. So let's do MBMC. Get the distance between them. So MBMC, the distance between them is 2, 4, 6, 6, right? I'm gonna ignore MA, which is the lightest. And then, okay, and then I gotta find the vertical, which is just 4. Wait. Huh? Okay, I'm confusing myself. I'm honestly confusing myself. 2 points of choice, and then get the center of distance between them. Oh, never mind. I getcha. Yeah, so 6 divided by 2, that's like 3. So then from here, it'd be like right here. Wait, no. I think I'm on the right. I think. Oh, there we go. 8. And then 4. 8, 4. Yeah, no, that's actually very. Yeah, no, that would have worked too, honestly. Because this is what I got just ignoring MA. I I picked MB and MC. Okay, for MB, and if it's Pythagorean. Wait, what? Okay, I don't know. Square root of 15 is the middle, and then split. Oh wait, you want me to do like? Huh? It's 4 and then 6, 6, and then I'm trying to do this in my head. Keep clicking the wrong tab. Is there a way I can draw on this part here? I don't think I can draw. Do you mean like do Pythagorean between like MB and MC, like connect it like here and then solve for this angle or for this line? And split it based on weight. So a ratio of 2 to 3, so it's more leaning this way. Wait. Yeah, no, I'm just lost. Sorry. Wait, find the distance between MB and MC with Pythagorean. Oh, wait. So I was getting onto something. Okay. So then it's, you know, it was 4 and then it was 6. 4 squared plus 6 squared. 52, right? Square root 52. That's about 7. So the distance between these is 7, right? And then what were you saying? And then use the ratio of weights. I don't know how to pull up ratios or do ratios on Desmos, but so 7.2 divided by 3 is like 2.4. So then 7.2 divided by, minus 2.4 is 4.8. So then like it does a 4.8 in between these, which would be about like right here, kind of. I'm guessing this is what you mean. Yeah, distance split on weight ratio. I probably should have graphed this on Desmos so that I think about it. That would have made it a lot easier to comprehend. But yeah, no, I getcha. Glad we were able to get it. W. It still led to D though, so I'm glad I was able to solve it to begin with. How much did they weigh? MB was 3. Oh wait. Oh, I thought it was a ratio of 2 to 3. I forgot. No, MB is 3 and then MC is 5. Whoops. I forgot the ratios. Silly. Yeah. That still leads up to the same answer though. Get the weight of one over the other. So 5 divided by 3 or 3 divided by 5. A ratio of 1.6. Oh yeah. And then multiply the distance we got between them. So 1.66 times, what was it? 7.2? Uh-oh. That was not it. I think I lost you for a second. Find the distance between. I got 7.5 for that, right? Yeah, no, I did get. I got 7.2. And then. And now for that new imaginary center for MB, do the same for MA. Okay, so I did lose you. Would this work? Hold on. If we got 7.2 when we solved with Pythagorean, and then you want us to multiply by 1.6 because of the ratio, that ends up being, wait, no, then let me do 3 divided by 5. Wait, I'm silly. 0.6. 4.32, right? And then do that imaginary center for M. Now for that no imaginary center for MB and MC, do the same for MA. Okay, so then it was like, I solved Pythagorean, so 2, 3, so then 4 plus 6 squared, or no, 4 plus 6, or no, 4 plus 9, I can't do squared, oh my god. And then it's 13, and then 13 square root, or square root 13. 3.6, so 3.6, and then the ratio is 1 to 3, right? Let me see. So then just like 0.33, or would it be 3? I'm thinking. Oh wait. All right. Wait, hold on. I'm gonna plot this in Desmos. I might as well. I did it the wrong way. 4, 6. And it was 8, 12. All right, what were you saying? 7.2 times 3 divided by 3 point. Wait, no. 7.2 times 3 divided by 3 plus 5, which is 3/8. Yeah, I definitely goofed up. Hold on. So you want me to do 3/8. Right? 7.2 times. Order of operations here with like. Wait. Let me just try that. 3/8. 2.7. And 3.6. And then the ratio was. So then it would be like. I mean, so that's for MB and MA. It would be what's it called? Would it be 1 divided by 1 plus 3? So then there's so much MB towards MC, the center between the two guys. Yeah, gotcha. I comprehend that part, thankfully. Okay. Yeah. So then 1 plus. So same thing for MA and MB would be 3 points. Where is it? 3.6 times, and then MA was 1, MB is 3, so then it would be 3.6 times 1, and 1 divided by 1.1 plus 3, which is just 1/4. 0.9. So those are our imaginary centers. Correct? I hope that's what you meant. I think so. I'm just gonna move on to the next question because there's another 29 to go. And then a third progress check. And then I'm done. Then I can say, I can go, Mr. Mason, yes, I studied over the break. That'll be great. The rope pulls the crate right across with constant speed. Wait, I gotta reread this. If they were equal weight, by Pythagorean theorem, distance we calculate divided by 2 is the center between the two. But have the 8, so not in the middle. I think I tricked you because we got the distance in the center, but we need coordinates. Yeah, I was gonna say, like, I wouldn't know how to get to 2.7 to the 0.9 coordinate based. You know what I mean? Like, yeah, the center is like for MB and MC, like the center was 2.7 away. But then again, how would I get that to show here? You know what I mean? Especially diagonally. It was like, I don't get it. Yeah, I'm just gonna go with intuition. Hopefully that's right. Let's see. Which of the following body diagrams could... Wait, let me see what... I need to reread this. I lucky forgot it. Rope pulls the crate right across. We got normal force, force of gravity, friction, and that's the force at the start. Crate moves across the surface. So there's more horizontal force. To compensate, there's more friction. So the speed doesn't change, so we gotta make sure we still have 2 horizontal on both sides. Or not 2 horizontal, but like equal horizontally. Also gotta make sure force of gravity and force of friction are like... I need to make sure it all adds up, basically. Oh, I accidentally closed out of it. Whoops. Please don't tell me it closed. Okay, we're fine. Okay. Let's see. Do these add up? 3, 3, 3, 3. Okay. A is wrong because according to the arrows, it'd be going upwards. Okay, 3 here, 3 here. 3, 3. Add 1, 2, 3, 4, 5. I think B would be going upwards. I might not cross that off yet just in case I'm blind. Okay. Okay, this one looks right actually, because there's 3 horizontally on both sides, and then here's 1, 2, 3, 4, and then 1 more vertically here, and that's 5 down. Yeah, no, C is the answer here. This one is just like going upwards again. Yeah, all these, everything besides C makes the box go up. Like you're like physically picking it up. That doesn't make sense. All right, let's see. Number 3. Figures show the forces exerted on an object moving on a horizontal surface. 2 different moments in time. Which compares to change of direction, if any, of the velocity. Okay. So we just gotta add all of that. There's 3 going negative horizontal. On figure 1, there's 3 going to the left, and there's 3 going to the right. So horizontally, there's it's like balanced, I guess. It's not moving, I think. Let's check horizontally in figure 2. There's 2 to the left and then 3 to the right. So it's changing in the X direction, that's for sure. In figure 2. Alright, and then there's 3 going down vertically, 3 going up here. So this is still not moving. Okay, it only changes in the X direction. The Y directions stay the same. So I think it's just boom. It seems to be no one that makes sense. Oh crap. Jeez, I always mess up these questions. Let me drink some more water. All right. Person stands on a scale in an elevator. There's 4 forces. P minus S, S minus P, P minus E, E minus P. So great. All of this looks the exact same to me. Because I might be a little dyslexic. Let's see. Which of the following currently ranks the magnitudes of these forces while the elevator is moving upwards? So there's a force of the person on the scale. First of all, let's think. Who stands on a scale in an elevator? You weirdo. I would love to one day recreate this just so I would understand what goes on there. Honestly. Because when I understood frame of reference, it was with cars, and I was like in the car to like figure that out. Like I like learned from experience, but like with this, I've never been on a scale in an elevator. Are we kidding? All right, whatever. Let's just focus on this. So there's forces acting on each other. Let's see. The force of the person on the scale. There's a scale. Okay, so they would balance out, right? Oh, I don't think this question's that bad anymore because they do balance out half the time. Force on the person on Earth. Force of the Earth on person. Okay, I'm pretty sure in each instance it has to be equal to the other. Wait, no. Because wait. Because if the elevator's moving upwards with increasing speed, at the end of the day, person's moving up. The person is going upwards. So the scale, does the scale push more? Oh, God. Let's just try to comprehend the answer choices. Okay, P minus S. So on the scale is equal to the scale. Okay, person acting on A, it says person acting on scale is equal to the scale acting on person. This makes sense, I think. Yeah. And it's saying that that is less than, or no, greater than Fe minus P, which is the force of the Earth on the person. Oh yeah, no, it's going up, so it has to be greater than that. And then P minus E, that's the force of the person on the Earth. That's where I'm a little lost. It lost me with that. Because he's not even on, well, he technically is on the Earth, but he's in an elevator. How does that relate to Earth? Yeah, when you move up, it gets pressed more to the ground. Yeah, I understand that part. If you start going up very fast, you'd be pressed to the ground. Therefore, the scale would measure more since you apply more force. Yeah, no, I thought that in my head. I'm just like thinking about force of the Earth now. Not only you wait, but the acceleration. Yeah, that part makes sense to me. Like hypothetically understanding. I just wish I was like there in person to experience it, just to like, you know, I guess cement it. Sorry, I feel like all those messages like randomly popped up. I was checking every once in a while, like all springed up on me. I might have been a little late to responding. All right, let's see. F equals P minus S. So the person is moving upwards, but is it technically due to the scale exerting more force? Or is it because the Earth is exerting more force? No, the Earth exerts it downwards. That wouldn't make sense. Let's just look at B real quick. F S minus P, so the force of the scale on the person is equal to force of the person on Earth. No. That one does not make sense to me. Yeah, I think there's two to confuse. Yeah, this one I think is one of the confusers. The force of the scale on the person and then the force of the person on the Earth. I think those are two separate things. Let's look at this one. Okay, force on person on the scale equals force of scale on person. That makes sense. Because I think that's the Newton's third law. I think. Wait, no. Whichever one's equal opposite reaction, I forgot. And then force on person on Earth equals Earth on person. That also makes sense. But then, yeah, I believe the force on the scale is bigger than Earth. Force of Earth to person and force of, yeah, that's complete BS. Yeah. I was trying to mess with me. Let's look at D, because I feel like I can cross off D. Force of Earth on person equals force on person of Earth is greater than this one. But no, this is saying that it's just greater than person on Earth. No, I don't think so. I'm trying to picture that. This does not work well in my head. Oh wait, and by same logic, this one's saying that. Wait. The Earth on person is greater than the person on Earth. If looking at A, if Earth on person is greater than person on Earth, wouldn't that mean we're going downwards? That one doesn't make sense to me. Because the Earth is dragging us down. You know, gravity, force of gravity. And if Earth on person is less than that, wouldn't that mean we're going downwards? I want to believe it's C. This question's really like messing with me, and I know that if it was on a test where I only have 2 minutes for it, I would have skipped it immediately. I would have like, look, he answered it like in 2 seconds. Yeah, I'm gonna go with C. I'm glad we can agree on that one. This one is scary. Oh no! I remember how much I hate this thing. To be fair, I hate most of physics. Actually, no, I like the concepts of physics. I love it. It's just, I wish I had more time for all of it, I guess. This is what this is for. I have a lot of time to answer all of these, so I have the whole day. This is going to be great. A 10-kilogram block is connected to both ends of rope. I got a notification. Let me turn that off. Don't want to deal with any right now. The rope passes over a pulley with negligible friction and mass. And it's on an elevator. Of course it's on an elevator. Oh yeah, let me check if the other one's out. I honestly doubt it. Because I'm pretty sure he has to grade it himself. Like, there's times... Oh, I don't want to enter my email. Do I have to? Hold on. Let me just see if I can open it from here. Nope. Hold on. Oh, 14 out of 18. That's not great. But it happens. Okay, we're going to finish. Actually, no. We barely started that question. So I'm going to go check what I missed on this one. I thought he had to grade it manually. There's no way I got this wrong. Oh yeah, this is what I was doing earlier alone. Hold on. What are the other ones I messed up on? Did I really got this wrong? Are you kidding me? Oh my god. No! I was really confident about it being 2G, and then it turns out it wasn't. Let me read why real quick. This option might be selected by using the equation. What? Okay, and then what was the last one? Ah. It's increasing magnitude. See, I got that. I probably used the exact same reasoning for this question that I did on the test, and I got it wrong. But I couldn't remember what reasoning I used on the test, so I got it wrong twice. Can you believe it? Great. Let me see what this is wrong. Increase isn't constant? Are you kidding me? I gotta remember that. I gotta engrave that in my brain. I don't want to mess that up for like the 3rd time in a row. Like, if this appears on the AP test and I get it wrong again, whew, I'm gonna go nuts. I don't know the rate of change increases. I need to see like a visual on that. Like, I needed like a visual representation of this, because this one did not. I don't understand why it's the rate of change increases. I thought it was perfectly linear. Let me see why I got the other ones wrong. Oh, I didn't mean to do that. Okay. This one was probably really easy. I'm just dumb. Let me see. This option would be correct if A2. Oh, wait, I'm an idiot. When I answer this, I recognized that A2 would be considered negative, and so I put it as the smallest. But then I forgot that there's the lines on the in between, which means like total, like absolute value or something. I forgot that. I forgot that there was absolute value there. That would have made it. Oh my god, I missed that one just because I'm silly. Yeah, absolute value. Okay. Oh well, that happened. Hopefully I don't make that mistake again. Let's see what got this one wrong. This is the ratio of the slopes of the lines. So I was not supposed to do the slopes. So represent the acceleration range, not the displacement. Oh, it was displacement. Oh, that's really easy. I'm glad I missed that one too. Area under the curve of the curve velocity is functional. Yep. That was really simple. Once again, I calculated the wrong thing. It's these. I'm surprised I'm like getting these small little mess steps. I should probably not have rushed through it as much as I did, because I think I spent. Oh, alright, bro. I'm gonna sleep since 12 a.m. Have a great time. Consider top colleges like AP classes. Not that it's the thing that you get except it's a card. Thank you. Much appreciated for your help. I hope you get a good night's sleep. It was nice. It was nice talking to you. Goodbye. Thank you for the luck. We are going to be. I will need it. I'm gonna need that luck. Okay, let me solve this again. Obviously, the area here is 2.5, right? And then 2 here. This is another. And this is just. Oh my god, this was so easy. That's sad. 2 squared plus 3 squared. That is 4 plus 9 and 30. Wait. I'm thinking. 4 plus 9, which is 13. 13 square root is like what? Square root 13. It's 3 point. Okay, never mind. I've lost myself. Let me close out all of these. Nice talking to you. Seem cool. Bye. You're cool too. Thank you so much. I appreciate it. All right, let's see. We're gonna do really good on the second assessment in honor of TDF Gitch. I probably mispronounced that. All right, let's see. Let me just solve this real quick. 2 here, and that's another. That's 3 in total. Actually, I can see that. Yeah, no. Oh wait, no. Why am I doing Pythagorean? It's base times height. Wait. Whoa, I might be slow. 2 times 3 is 6. Yep. Okay, yeah, no, that makes so much sense. It should have. I should have thought a little harder. Now, why did I get this one wrong? This one was a real pain. I should maybe select by using the equation. Let's see. Because I really bullshitted this one. I did not know how to solve it. I'm going to ask ChatGPT later to do it step by step, just so I can process it. Because I really need a step by step, because like sometimes these answer explanations, they're so buns. Sine theta. Yeah, okay, so that makes sense. The vertical component is sine. And side to side is points. The vertical component at this instant is y equals 0. Using Vy minus GT time it takes the voltage. Wait a damn minute. Oh crap, that's just the first equation. Vy equals Vi. Oh my god, wait, that's easy. And then solve for T. T is. Wow. But then how does that get horizontal distance? No, I'm thinking about it. using x equals VOT. Then how do you get that? Or is this just a blatant equation that I should have understood? Actually, no, that makes a lot of sense. Of course, the distance equals velocity over times time. That makes sense. Where VOI equals VO cosine 0. Wait, what? VO. What? Vertical component of this is equal to cosine theta. Oh yeah, that makes sense. And substituting for the time. So then it was Okay, I think I somewhat understand this actually. Okay. Let's see. Was there any others I missed? I keep clicking the wrong button. I got a 78. Wait, seriously? Oh shit, that's bad. But in class, he really curves these, so that actually would curve to like a 90 something. But I'm still worried about the actual AP test. That's not good. This is not good at all. That's fine. We're fine. Okay, let's continue on. I'm not taking any breaks. We're just gonna go straight back to MCQ2. I kind of, out of curiosity, want to check how many there is for Unit 3. But then again, I feel like I'll get really demotivated if I do. So we're not going to do that. I need a grind, dude. I need to grind. I'm grinding all these questions. How many hours have I been streaming for? It's almost been 2. Oh my god, this is going to be my longest stream ever. Okay. 10-kilogram block is connected to both ends of a rope. The rope passes over a pulley with negligible friction and mass. The entire assembly is placed in an elevator. The elevator has constant acceleration. I don't remember this. Tension force. Oh, I forgot tension force. Okay. FBD. I need to refresh. Let's draw our FBD. I'm not leaving this chair unless I have to go do something for my family. That's a terrible circle. Okay, FBD. We've got 2 meters upwards. Wait, no, let's think about it. What are we solving for again? What's the magnitude of tension force in the rope? I don't think I need an FBD actually. Okay. I'm really thinking about this. I feel like I've forgotten the basics. That's my issue. I've forgotten everything. I'm not joking when I said I'm relearning. Okay. I can't even pull up like the slides we used in class. It's all closed. Whatever. The elevator has a I'm thinking. How do I What? Wait, let me pull out my notebook. What am I doing? I should have taken out my notes like 10 years ago. Hold on. God damn it. This one. I don't label my notebooks. I probably should. It's not this one. Maybe it's this one. No. Found it. See, this would have been a lot more useful if I pulled it out earlier. It's fine. We're fine. Hold on. Let me just refresh this. There we go. Let's see. Okay, so the first thing I write about was like center of mass. All right. Let me see. Talk about ideal strings. Strings of no mass. This is also an ideal string in this question. It's also called light string. There's a loud car driving by. Tensions are the same in ideal strings, but increase from mass otherwise. Okay. What's the equation to get newtons? I forgot. Did I write it anywhere here, or did I just think that's a given? Oh god. I don't think I wrote it anywhere. This is about gravity, friction, spring constant. Oh, I don't want to think about spring constant. Oh, great. I didn't write it anywhere. Hooray. Maybe it's in unit 1, actually. That would make a little more sense. I didn't write it there either. We're fine. Notification. I subscribed. Thank you. Goated. He's goated. That dude's goat. Alright, let's see this. Let me pull out my giant textbook. You guys can't see any of this, but I just pulled out my, like, huge AP Physics 1 Premium Prep Princeton Review Edition. I would recommend it because one of my friends got it. Okay. So this is unit 2. Let me find what unit 2 is. Okay, so this is page 125. It starts around there, I think. All right. Force and translational dynamics. All right. Let's see. Why am I getting notifications? Wait, one of my best friend is texting me. Hold on. All right. Let's see. I'm still looking through it. I haven't actually read through this book. I probably should have done that a while ago. Force equals mass times acceleration. That's like the main equation we've used, and I forgot it, dude. I was trying to figure out how to find force. I forgot force is newtons. Are we kidding me? Newtons equals kilograms, or yeah. That makes so much sense. It's not even funny. All right. Now I can solve this. Now I can solve it. Hold on. I think I'm gonna have to read a bit more. I'm gonna read through this whole book later. Honestly, it might be like my savior. I still haven't read through it. You're not smarter, Jerry. I got a higher average than you last semester because I'm freaking awesome. I'll tell you. Yeah, I'll text you. He wants me to play League of Legends, guys. Boo him. Yeah, totally. Yes, sir. All right, let me see. So F equals MA. I probably should have written that down a while ago. Let's see. F. Oh, that's really skinny. F equals MA. Only the equation we use the entire unit. Yeah, no, I know there's no guys. It's literally just us. Yeah, I know, Jerry. I know. You don't have to remind me. Whatever. Okay, F equals MA. So we're looking for force, right? This would be easy. I could calculate it, but then it's also in an elevator, which makes my life a lot harder. Sorry, it's friggin' texting me again. Let's see. The elevator has a... Okay, I'm going to solve this as if it's not in an elevator, so I can process this. Let's draw this real quick. We've got our box of 10 kg, right? And then it's like a pulley, right? Okay, that's our drawing. Now. 4 equals mass times acceleration. So G, we're gonna use G here in this instance. So it could also be F equals mg, right? I think that counts. And the mass here is 10 times, and then 9.8. So then the newtons would have been, it's like 98 newtons. Jerry is still texting me. Where did I? He's gonna post my fucking... Okay. Alrighty. Let me see. Magnitude. I don't know how this translates when there's an elevator. The whole concept gets 10 times more confusing to me. How does that change it? I'm assuming it'd be more weight. The only one that would be more weight is this one. But then, hold on, let me look for my freaking textbook. Maybe there's something on it. Maybe there's not. Who knows? Hopefully there is. So like page 125. And I'm just gonna run through it until I see what looks like an elevator. Please have something. Oh, hey, it's talking about police here. Wait, we might be getting somewhere. No. Yeah, no, it's just review questions. Are you kidding me? Feel free to ever, you know, like, explain shit for once. No one, even in Mr. Mason's class, even in my physics teacher's class, he'll like teach us a simple concept and then it goes like 10 times harder and that doesn't make sense. It sucks. Let me read the stuff about the pulley. We're solving for MT still, or FT. Huh. The textbook is not helping. Okay. Now I'm a little confused. I already was, but you know. Still getting texted. I sound stupid right now, I know. Maybe my actual notes talk about an elevator. Hold on. They don't. Great. I'm lost. I'm actually lost. I'm assuming the tension increases, and I'm assuming it's this, but I don't know how. Wait a fucking minute. Okay, so instead of it being 9.8, because like usually like we count gravity as 9.8, my teacher said you can also use 10, right? So huge should be out, so then it'd be 100 newtons, right? But since it's accelerating at 2 meters per second, what was it? Yeah, 2 meters per second squared, right? Right. What if we multiplied these two? Yeah, what if we multiplied these two? And then so that would be 20, right? And then you add it together to get 120. Oh, I get it now. I mentioned didn't even load. Is it even doing anything? So the elevator is accelerating upwards. Everything inside feels heavier. You can treat the spacing and effective gravity. What the hell is effective gravity? So you add it together. So 10, it would be 10 plus 8 to get 12. And then so you would use 12 instead of... Oh. Oh, and I was still wrong. Woo! So the answer is actually 60. I'm still lost. I'm even more lost. How is this even possible? Wait, so since there's two strings, the tension divides by 2. Right? What? What? Oh! God damn it, man. Okay, I get it now. That upset me a lot. Okay, so let me restart this from the beginning. We're gonna erase this all, and it's gonna be a proper solved question. Right? That's a terrible box. That is a worse box. 2ms squared. So since you add the accelerations together somehow, but the elevator's going upwards. That means I thought you would have to subtract it then. This is, what? Effective gravity. I've never once heard that in my life. Just remember it goes heavier, right? And so when I explain it past that, let's just say it gets heavier. Okay, so then 10 plus 2. G equals 10 plus 2. Right? Because it's also, this is acceleration. The gravity is also acceleration. So wow. Okay. This question pissed me off. Force equals mass times acceleration. F equals mg. So now we do F equals 10 times 12 to get 220 newtons. 2 strings. So then it's 120 divided by 2 to get 60 newtons. Hooray. That took me way too long. Wow. Oh crap. I forgot all of this. Figured the planets A and B with masses 2m and m. How does a planet have more mass than a star? I will never know. Oh no, it's talking about these two planets. Never mind. It makes sense still. Okay. Planet with masses 2m and m respectively orbit a distant star with mass m shown. Planet A, since it's 2r from the center of the star, and planet B is just or from some star. I forgot all of this. After the following is correct expression for the magnitude that forces are now planet B. Okay, so there should be forces being exerted from both sides because planet everything pulls. Even you. There's no one watching the stream. Yeah, so it's being pulled by planet A and the star. Now, I'm gonna keep brain farting. The equation for the gravitational force of something, it is F G equals G and then M1 M2 divided by, I think it's R squared. Let me double check that. Because I know there's two different FGs. And I know their equations are different. So I'm being paranoid. Okay, never mind. We're good. Okay. Let me see. Okay. I'm gonna bullshit this. Watch. I keep clicking the wrong freaking tab. I'm going nuts. I don't know how to use this equation. Hold on. R is the distance between centers of mass. But there's three objects. Wait. This unit's kind of kicking me in the nuts. I won't lie. So there's three masses, correct? I'm getting kind of hungry. Yeah, my stomach just rumbled. I need to finish this shit. We're not taking breaks. If I have to, I'll eat something up in my room. I'm not allowed to do that. I can't even. Let's see. I'm really thinking. Let's just kind of bullshit this. G, right. Let me just a little bit over here. G, right? And then we've got one mass of 2m. We've got another mass of m, and then a mass of m, right? Divide that by r squared. I'm so fucked. It doesn't make sense at all. I need to read up. Hold on. Let me find my notebook. Damn it, man. I'm actually pissed. Alright, let's see. I like how my book smells. It smells sophisticated and ancient. Whoa, 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 whoa. It doesn't even talk about it. Yo! Where is force of gravity here? Where is it? There's nothing. They just didn't mention it. Read that. Oh, it's in the other chapter, the different chapter for some reason. Okay, so here's some stuff about circular motion. Okay, let's see. Newton's law of gravitation. God, this is confusing. Doesn't even explain it that well. It just explains it if there's two. I'm so lost. Oh, I think I subtract the two from each other. So we have two different equations. One of them being... No, but that wouldn't... Huh? Hold on. Never mind. Okay, let me see. We're gonna try this. What the hell? G, and then 2m m divided by r, capital R squared, right? But then there's also, it's net force, and they're in opposite, they're pulling from opposite directions, so we would minus, I believe. And then let's do another one of these. G, and then it's m, capital M, divided by r squared again. Planet A is a distance 2r from the center of the star. I think this is getting somewhere. How the hell did we subtract this? Honestly, I might have to throw this into ChatGPT as well. I'm so far gone. Can I really not just put all three together? Yeah, let's just fucking... Whatever. Another failure. They're equal to each other? Wait, what? Okay, no, subtract their magnitudes. Okay, I was right about that. Where did the 2 come from? The heck? Okay, I don't know what happened there. We are on question fucking 6. We breezed through unit 1, and now we're still on question 6 somehow. Isn't this beautiful? What? Where did this 2 come from? Where did that 2 come from on the left side of step 3? Planet A's mass. What? Huh? Where's capital M here? I'm so lost. Is that not the same shit? Okay, never mind. I had the same fucking thing. Never mind. I just have to simplify. I'm very hungry. Yeah, so that's just 2m squared. I don't know the g goes up there with it though, so it's g to 2gm squared r squared minus g and no divided by r squared. No? Now how do I solve for this? How did you factor out common terms? Because that's the one part I don't get. I haven't been taught that trick, I guess. Let's do it slowly. Oh, that doesn't painfully. So you just flat out kick them out. And, oh yeah, this is a little bit of intuition. AB plus AC equals. Oh shit. Huh. Where is my writing stuff? Here. Okay, so the common terms here are G, or what would I count? Because there's a square there. Squares. Okay, no, yeah, you still keep an M. And then R squared. And then for what the difference is M. There's another M, but they're in opposite directions, so you would minus. There's a 2. Which side does that go to? It's the 2M. Well, I guess because we're on the same side to start it. Okay, so then minus 2M. And that's our answer? I guess? Okay. You know what? I'm just gonna take it. It's 5 p.m. At this rate, I'm finishing at 9. The block of mass M is held at rest against the vertical wall. Divided by force FA. The force F on the block. Static friction. Dude, I don't remember how static friction works. I'm so mad right now. I feel so helpless. And the magnitude of FA is larger than the minimum required magnitude to keep. Huh? Is it not just this? I feel drained. I feel like actually fucking drained. Let me see something. Pulling out my notebook. Fs is smaller greater than us times Fn. Yeah, it's just okay. That's literally just the equation for static friction. Are we serious? Is this a trick question? My head's gonna start hurting. I swear. I'm gonna put this in ChatGPT. I want to see if it's a trick question. Fuck. Kill me. So they equal each other, yep. What? Friction simply adjusts to balance gravity. Upward. I guess that makes sense, but I'm still pissed. Whatever. Another springs, great. Another thing to give me a headache. Another thing. There's so many questions left. Hold on. All right. Let's see. A block of mass. Wait, she responded. Hold on. A block of mass M is attached to a spring on an inclined plane that makes an angle theta with the horizontal. Initially, the block is held in place with the spring. Hold on. The block is then slowly lowered until it comes to rest at equilibrium at displacement x theta from its original position. Which following expressions is equal to the spring constant of the spring. I don't fucking know. Let's see. Okay, spring constant. What? What? That's the stiffness of the spring, right? What's the equation for spring constant now? I don't know. For a moment. I'm like, you're losing it. The spring constant. Okay, we got a new equation to put on. Did I not just refresh? Okay. The spring constant is a lowercase k equals the force divided by, where did I write it? The distance. Now, the distance is xo, correct? Why is this one so, why is it take so small on this one? This one, I don't think it's that bad now. The force is just, so wait, where's theta? Theta's right here. Pretty sure it's mg cosine theta. I forgot how these angles work, but I'm pretty sure it's mg cosine theta. I don't have it written down here. Yeah. mg cosine theta, maybe. Because alternating angles, I think. Let's not Google Gemini because I ran out of stuff on this one. Gemini. I think it's B. I just gotta see. I think it's called alternating angles. It is cosine for the perpendicular component because that component. I'm fucking lost. Oh my god. Kill me. I want to die right now. Hey, it linked to organic chemistry tutor.
In this video, when dealing with inclined planes.
Let's see.
In this video, I want to review some formulas that you need to know when dealing with inclined planes. Now, let's say if you have a box that rests on an incline. The force that extends perpendicular to the surface, this is the normal force. The weight force is in the negative y direction as always, so that's mg. Now let's say we have an angle. Now what you want to do is you want to draw this line, but in the other direction.
Yeah.
And you want to draw a triangle, making this the hypotenuse of the triangle.
Oh shit. Oh wait, 1 second. Let me go
So
back. I am back, and I will be grabbing coffee in 5 minutes. I need it. Desperately. Let's keep watching.
It's important to understand that this angle is the same as this angle. For instance,
I forgot this, but this was like common knowledge back then.
let's see if we can fit it in here. Let's say it's 30. And this, we can see it's 90, which means this has to be 60. And this is perpendicular. Like this line is perpendicular to that line. So which means this is 90 as well. So therefore this part has to be 30. Which means theta is right there in that triangle. So let's focus on that triangle.
MG
Now,
cosine theta.
let's say this is, let's call this x and let's call this y. In terms of mg, what is x and what is y? What would you say? Perhaps you heard of the term SOHCAHTOA in trigonometry. So the first part means sine is equal to the opposite side divided by the hypotenuse. And this is cosine is the ratio of the adjacent side of the right triangle divided by the hypotenuse. And tangent is the ratio of the opposite side to the adjacent side. So cosine theta is going to be equal to the adjacent side divided by the hypotenuse. So that's x over mg.
Cosine theta.
Now, if you cross multiply and solve for
Cosine
x,
theta.
you'll see that x
MG cosine
is
theta.
mg cosine theta.
Goated. Okay. What was I doing? Yeah. It's MG cosine theta. Woo! Is this circular motion? Are we deadads? Ball of mass M is attached to a vertical pole by a rope. Travels in a horizontal circle. Rope is attached to the pole. God, I'm tired. I'm tired, boss. The ball travels with constant speed v, which the following is a correct expression for the tension force in the rope. Okay. F equals MA. Let's start with that. Okay. And then there's a massive mg. Or is there? I don't remember this. Dude, I'm so fucking cooked. At least this isn't a test. Let's see if I ever talked about this. Spinning circles. Okay. Centripetal force. Oh, I thought that was third unit. I guess not. God. Okay. Let's see. So for the tension force, so there's my whiteboard. Another equation of C equals, oh, MAC. Never mind, that's not really a new equation. This is force equal plus time simulation. All right, let me write this over here. C equals MAC. That's a terrible one, so I'm redoing that. Okay, next spaced apart. I think I might have OCD. Okay. Now, we have mass. Our acceleration is just v squared, right? I'm looking for the tension force. How the fuck do we get tension force from this? I'm just gonna write mv squared. Right? Would this be considered tangential velocity? Sine of theta. Force equals mass times acceleration. What the fuck? I'm lucky losing my shit. Okay, so this has FT. Let's see what this one looks like. Didn't really help. I don't want to keep relying on AI, but also like, there's nothing fucking teaching me. Let's check the huge textbook. It doesn't cover it. Okay, 1 second, I'll be right back. Yes, sir. I have some caffeine now, so hopefully it'll help me push through. Okay, let's see. Force equals mass times acceleration, but then like, how the fuck do you get it from here? Wait, FC, and FC was. Wait, maybe I should use AC instead of FC. Hold on. Okay, now it's a new equation. AC equals V squared divided by R. Mine says I put VT squared. Oh, it's because it's tangential velocity. That's why. I was a little confused. But no, that makes sense. That makes a lot of sense, actually. Okay, so AC equals VT squared, right? And then so over here, we're gonna VT squared, right? So then I'm just gonna write v squared. And r is sine theta. Right? And where does L come in? I'm thinking. I'm just glad we figured out where sine theta is, right? F equals ma, right? And then so the acceleration, this is the centripetal acceleration. So we also need And then there's a second acceleration, which is the gravity one. So this is, hold on, this is AC, right? But we still need to do the full thing. So now for FT, this is the acceleration that we're using. So it's MAC, which ends up being and then the whole thingy we have, so v squared sine theta, right? I'm just making it look nice. Okay. But we're also, wait, what? Something's not adding up here. I guess MV's on the top actually, so let me actually do this. Oh, now it looks weird. I'm just gonna redo it all. MV squared divided by sine theta. But where does the L come in? Do I just shove it down there? Honestly, I'm considering it. I'm not entirely sure what the link has to do with it. I say we solve the hard part. So I want to just ask Gemini how they did this. Where does L come in? Because I'm this close to grasping the whole thing. I just need that final push. Let me drink a bit more coffee. I think I need to refresh it every time I do this. Because it still tries to answer old questions when I don't want it to. It's annoying. Why is he saying cosine? The hell? I think I need to show him the answer choices. Because, like, what the fuck are you talking about, man? Please don't be wrong, Gemini. I will be really upset. Wait, this is where the L comes in. Wait, what? Oh my god, that's so fucking simple. How did I not understand that? Sine 0, it's just sine SOHCAHTOA, opposite over hypotenuse. If r is opposite, it's then r divided by L, and therefore solving for r. Then, oh my god, dude, I feel silly. I feel silly. Whatever, it is this, right? B. Yep, okay, great. Alright. Let's hope the other ones are easier because I've just been back-to-back ball breakers. Force keeps the textbook at rest, which the following free body diagrams represents the force exerted on the textbook. Let's see. Well, since it's not moving, you have to equal each other. So this is 1, 2, 3, 4, 5. 5 down. 1, 2, 3, 4, 5, 6 up. Wrong. These 1, 2, 3, and 5 up. 5 down. 5 up, 5 down. 5 up, 5 down. Okay. Now I need to look at horizontals. 4, 4, 3, 4. Wrong. That's not how normal force works. It's B. Okay, that one was simple. I say that and I like 100% got it wrong. A rod with uniform density, so it's equal. Centered on x equals 0. Connected to the ends of the rod, center mass. It's located at. Okay, so M2 is heavier than M1. If the mass of the two spheres is doubled, but the mass of the rod does not change. Where will the new center mass is it not? Wait. If the mass of each of the two spheres is doubled, but the mass of the rod does not change, where will the new center mass? Is it not the same place? Is this a trick question? I'm gonna ask Gemini just so I just want to double check this because I feel like this just is not the same friggin' place. Come on, please I see, please I see. You're kidding me. You're kidding me. What the fuck? How does this even make sense? Look at all this. What the fuck is hell? Left side. Plus alpha right side, yeah, because we need to specify. Because we had to specify that. We were able to confirm that to be fucking begin with. I want to kill myself. guess it makes sense. Whatever. This should be easy. I'm just gonna pick that. What is that? What is translational? Oh my god. Equilibrium. Oh. I just say equilibrium. Or at least my teacher does. My sister's doing something weird right now. Yeah, okay. I think it's this. Let's ask. Okay, or not. Because velocity also includes direction, so I don't think D works. If it's D, okay. Good. We're pushing through. Pushing through. The three scenarios shown in the figure, forces are exerting and down. Okay, so C has the least, I'm guessing, because, you know, there's only one block fucking moving. Would it be that? Let's ask Gemini. If you can't tell, I'm somewhat tired. I'm fucking drained. You could just tell me the answer. You're kidding me. Is it asking net force? It doesn't specifically say net force. But would it cancel out? I guess, but the question should be more specific than that. Jesus. It doesn't say net force or shit. How am I still on the second one? I don't fucking know, Jerry. This has been like nightmare on hell, like on Earth. This is hell on Earth. A hypothetical planet has twice the radius of the Earth, twice the mass of the Earth. if an object has weights on the surface of the Earth, what would the object's weight be on the surface of a hypothetical planet? I feel like this one's easy. Would not just be divided by 2. Gemini's gonna fucking prove me wrong. Watch. Watch as I'm proven to be an idiot. Please. Hooray! See, that one made sense. We're over halfway done with the second one. It's been like a fucking hour and a half. Or potentially the card. Right. I don't think this is worth it anymore. At this point, I clearly don't know the subject. I'm gonna just ask my fucking physics teacher. I'm just staying after school more. I don't have time for this. I generally have to do shit. It's already 6. Alright, yeah.